welcome to Tuesday's edition of Cracking the Cryptic, where today we're going to be taking a look at the puzzle on the screen, which is called Unity, and it's by Playmaker 6174. Now, there are two things I know about Playmaker 6174. The first is that they are an exceptionally good Sudoku solver. I think they do an awful lot of the testing over on our Discord server. And the second thing I know is that this puzzle Unity is, I think, number 11 in a series of puzzles that Playmaker's been making over on Logic Masters Germany, and I think that's called something like the Battle of the Archers series, because they all involve in some way or another arrow Sudoku. Now, we have had some of the other puzzles recommended, but this one on screen has been recommended by loads and loads of people. It's got something like a 98% approval rating on Logic Masters Germany, a lot of beautiful comments. And it's supposed to be approachable, so we might even be in for a relatively, I say relatively simple solve. I felt that my brain was being broken yesterday, but hopefully there will be no breaking of brains today. Now, before I read you the rules of this one, the first thing I want to do actually is to say hello to Isabella O'Connor. Isabella, I know that you've been in hospital a lot over the last 5 months or so. And I believe that you've been watching Cracking the Cryptic and finding some solace in our, or solace depending on your pronunciation, some solace in our videos. Well, we're very pleased to hear that, but mostly we just want to wish you all the very best with your recovery, and we hope you keep cracking and that you continue to hone your Sudoku skills. So get well soon, Isabella, and yeah, that's the first thing I wanted to say. Next thing, slightly more prosaic subject, The Witness. Thank you so much if you joined the stream last night. We had a lot of people watching me do battle with a variety of puzzles, including those colour puzzles near the end, which I swear interrupted my sleep last night. All I could see when I closed my eyes was flashing images of colours. So I'm quite glad to have overcome that hurdle. And yeah, thanks again for joining me if you did. The videos are, you can watch, I think there's now 7 editions in which I'm tackling The Witness, and they're all available on the channel if you might enjoy that sort of thing. Anything else to mention? Oh, well, we are really closing in on 400,000 subscribers now. I think we're only maybe 5,000 subscribers away, which seems like a surmountable number. So if you do watch the channel and you do enjoy it and you're not subscribed, please do consider it. We would be most grateful. And at 400,000 subscribers, we are going to make this video. We've had lots and lots of questions. So if you have a question for us, send us a question at crackingthecryptic@gmail.com, and hopefully we'll get a chance to answer the question in the video. Now, all that said and done, let's get on with some Sudoku solving. What have we got here? We have got normal Sudoku rules apply. That's good. Digits along an arrow must sum to the digit in that arrow's circle. So that's normal arrow Sudoku rules. Digits along a purple line form a set of non-repeating consecutive digits and can be in any order. So these are Renban lines, these purple lines. So let's just make sure, if you're unfamiliar with these rules, how they work. Basically, we add up these 3 cells along this arrow, and whatever the sum is, we put it in the circle. So if this was 1, 2, and 3, we would put 6 in the circle, not 7. That's a misprint. Now, the Renban lines, they have to be a consecutive sequence. So let's say that we discovered that this arrow here was, I don't know, 4, 5, 6, not arrow, this line was 4, 5, 6. Then what we don't have to do, it's not like thermometers where you have to increase from one end to the other. You could absolutely do something like that. That would be a legitimate way of filling this Renban line. So, do have a go. The way to play is to click the link under the video as usual. Now I get to play. Let's get cracking. Now, let's get cracking with a very cluttered box. We have a very cluttered box 5. Now, the simple question I think to ask in box 5 is, where are we going to put a 9 in box 5? Because there is only one cell that will work. Each of these arrows, look, is at least 2 cells long. So we can't put a 9 on any arrow. If we put a 9 here, whatever we add to it is going to make this circle a 2-digit number, which is impossible. So the 9 can only go in the middle. And probably I was about to say probably 8 will be restricted as well, but 8 can't go on the 3-cell arrows. So we know that the 8 is... Alright, that's a little bit interesting. Look, we know there's an 8 in one of those 4 cells. Therefore, we know one of these 4 cells has to be a 9. And one of those 4 cells has to be a 1 to accompany the 8. But there is not really a good way of me pencil marking that. If I start pencil marking 9s into those 4 cells, I think I will get confused. So maybe what we should do is to think about maybe the Renban lines. I'm actually wondering about mod 3, looking at column 1, because I do know a Renban line, a 3-cell Renban line, if you add up the digits on it, is always going to be divisible by 3. And we know that mathematically. If we think about the quality of a Renban line, a 3-cell Renban line, we could express it mathematically as the middle digit being x, the lowest digit being x minus 1, and the highest digit being x plus 1. So we add up the Renban line, we get 3x. 3x is divisible by 3, obviously. Now, because of the secret, and the secret, if you're not familiar with the secret, where have you been? But I'm going to let you in on the secret. The secret is that in any complete column, in any complete row, or in any complete box of a Sudoku, you're going to see the digits 1 to 9 once each. So this column contains the digits from 1 to 9 once each. I don't know what the order is, but I don't need to know. I just know that the sum of those digits is 45. And 45 is divisible by 3. And that means, because that's divisible by 3 and that's divisible by 3, these 3 digits are divisible by 3. And that tells us that that digit and that digit are the same, they have the same value, mod 3. Because if these 3 are divisible by 3 and those 3 are divisible by 3, then whatever that goes into those 2 squares must be the same. So if this, I don't know, let's just prove that to ourselves. If this was 1 and this was 3, then in order for this to be divisible by 3, we're going to have to either add 2 to it or 5 to it. And then in order for these to be divisible by 3, of course, this cell must have exactly the same quality. So in fact, these squares here, well, if that was a 1, 3, this would have to be a 2, and then this would have to be a 5 or an 8, and this would have to be etc, etc. But knowing that these are the same mod 3 might actually not be useful. So I feel I've got on a digression here. Oh dear. And it's looking a bit grim over Bill's mothers. Let us try and find something else to look at. We shall look at... maybe... I'm reluctant to do this, but maybe we can do something with the fact that we know those cells add up to 36, and that, again, that's just a result of the secret. We know the box adds to 45, so 45 minus 9 is 36. 36 plus 12. 40. Ah, yes, okay, that is the... Right, I have the break-in, I think. Let's do this more seriously. This ring of cells here adds up to 36. What's the minimum these 3 cells add up to? Well, if we put 1, 2 and 3 in there, they would add up to 6. If I put 1, 2 and 3 in there, they would add up to 6. So altogether now, this set of cells here, which are all of the arrow cells emanating from these syzygies of circles, add up to 48 at least. But what's the maximum I could ever make this syzygy add up to? Well, I could put 7, 8 and 9 into those cells, but I couldn't put any more in. 7, 8 and 9 add to 24. So I could do the same down here and get to a maximum size for the 2 syzygies of 48. And that's the minimum size of the arrows. So that must be where we reach an equilibrium. Now, what does that mean? Well, that means that we've now learnt some things. We've got 1, 2, 3 triples. We've got a 7-8 pair in column 5, a 7-8-9 triple in this row, and a 7-8-9 triple in this row. So this arrow cell now, oh, and this one as well, right, these two arrow cells now can't be a 1, 2 or a 3. 5, 6, but unfortunately, oh, we can't put 9 in the two circles because of the 9 in the middle box, so the maximum size of this is 8, which means the maximum size of this is 7. So those two squares there I think have to be 4, 5, 6 or 7, leading up to a total of 5, 6, 7 or 8 in the circle. Yes, that doesn't seem to be useful. Maybe we'll come back to the middle box. Can we do more with the high digits in here now? Oh, well, okay. I can put 7 into the same cells I've put 8 into. Look, I can't put 7 on one of these 3-cell arrows, because if I do that, although I could in theory do something like this, this will still equal 9. So the minimum I can ever make a 3-cell arrow add up to, if I put a 7 on it, is 9, and 9 can't go into the two circles that come off the 3-cell arrows. So that means the 7 has to go into one of those 4 squares. Now unfortunately, because of the way these arrows kink, I don't think I can perform the same trick with 6s. I could put a 6 here and then surround it with double 1, put an 8 in the circle, and that's rather annoying. Oh, I've got 1, 2, 3 here as well, so sorry, I should have appreciated the symmetry. These two squares have also got to be 4, 5, 6 and 7 then. Oh right, that's lovely, absolutely lovely, right. Now I'm going to ask a very simple question. Where does 1 go in column 1? And I don't know where it goes exactly, but I know it's in one of 2 cells, because if this Renban line has a 4 on it at a minimum, it can't have a 1 on it, because if it's got 4 on it, say, the minimum we could get down to would be 2. So you can't put a 1 on this Renban line for exactly the same reason. So the 1 must be up there. Once you get a 1 on a Renban line, we know the composition of the Renban line. It must be 1, 2 and 3. And we know the 1 is in one of those 2 cells. So I'm going to pencil mark that. That doesn't see these, this 1 here doesn't see those 2 cells. So we can't get rid of 5 from there. But surely 2 is restricted as well. If I put 2 there, yes, yeah, this is really, really simple, but beautifully, it's crisp and clear, this logic. Let's now think about where 2 goes in column 1. If we put 2 on this bottom Renban line, which it could go on, it could be a 2, 3, 4 Renban line. We can't put 2 on this one because the minimum digit is 5 in the circle. But 2, 3, 4 here forces this square to be a Schrödinger cell, because this would have to simultaneously be 2 and 3, which is impossible. So there is no 2 on that Renban line, so there is a 2 up there, which means we've now got, we've placed a 3 here. 3 must be in one of those 2 cells by Sudoku. Now, what does that mean? That feels like it should be an enormously powerful breakthrough, but I can't immediately see. Yeah, I have seen something else though. I think we can still carry on working in this neck of the woods because of the 7, 8, 9 triple. So this square here can't be a 7, 8 or a 9. And that means this Renban line cannot have a 9 on it. So the question we should ask is where does the 9 go in column 1? And the answer must be in one of those 3 squares, which means these 3 squares are 7, 8 and 9. And that means that's not 9. So 9 is in one of these two. This is a 7, 8, 9 triple. We now can't put 7 in those two. This is gorgeous. So 3 now must be on this bottom Rembrandt line. Which means 3 is in one of those 3 cells in box 4. And do we now know more about those 2 cells? That's what I'm wondering. So if this is 8... Oh, you rotten thing. Look, if this is 8, you can go double 4. That's very annoying. So if this is 8... right, okay, if this is 8, you can't use 5, because you'd need a 3 here. The same is true there. So if this is 8, there is no 5. What if it's 7? If it's 7 and you put 5 into one of those, you can put 2 on the arrow, I think, so that's not necessarily helpful. Okay, so we might have to do something else now, I think. The question is what? Where's the weak point in this puzzle now? Ah, I know what it is. I've got to come back here, haven't I? This is really cool. So now I can use the logic that I discovered at the start that was useless, but it's now not useless because we know those 2 squares are the same mod 3. Well, this is 0 mod 3. This is exactly divisible by 3, so this needs to be exactly divisible by 3 in order for maths to work. So that's a 6, and now that square is a 1 or a 2. And that square's not a 6. Right, and now whatever... This is interesting as well, because whatever that digit is, it finds a pair in these digits. And this square cannot be a 1, 2, or a 3. So this digit repeats in exactly that cell in box 7. So this is a 1 or a 2. And then it's going to find a friend in these 3 squares. So there is a green cell in one of those 2 cells. Now this is a 4 or a 5. So, what's this digit? That's what I'm wondering. If this is a 7, this can't be a 4 because that would be a 3. So if this is a 7, this needs to be a 2. If this is an 8, oh, bobbins, you can get the double 4 thing going on, can't you? So this is a 2 or a 4. And if it's 8 and 5, you need a 3. Okay, well this digit is quite restricted then. It can't be that much. Right, right. Let's keep going. I'm incredibly impressed with this puzzle so far. Every little deduction has been absolutely gorgeous. I think I found another one. I've got a 1, 2 pair here and a 1, 2 pair in this triple here. So where am I putting the digits 1 and 2 in this box? Not there, not down here. We've identified one of them in a green cell. So one of them, there must be a 1 or a 2 in this domino. But that means there's a virtual 1, 2 pair in the column, combining the green with whatever this is. So that can't be a 2. I think that has to be a 4. And therefore, that has to be a 4, and that has to be an 8. That feels right, doesn't it? Now this can't be a 4. So if that can't be a 4, is that pushing this value up? Yeah, I mean, this can't be a 5 anymore, can it? And it can't be an 8 anymore. So this is 6 or 7. So this can't be 7 anymore. So this is now 1 or 2. Oh no, I thought for some reason I was going to get a 1, 2 pair. But actually, those 2 digits are most certainly not in the same row of the Sudoku. Now that square can't be a 7 or a 6. It sees this square. So this square is restricted as well. 4 would have to go with 2 or 3. And 5 would have to go, oh, 5 could go with 1, look. Bobbins. Right, okay, so we can't quite resolve what's going on over this side, I don't think. But this 8 gives us a 2 here, just by maths, in order to make 6 add something equals 8. So this is not a 2 over here. Does that mean this is restricted again? No, it doesn't. It can still be 5 and 1, or 4 and 3. No, okay, I don't think that is quite done yet. What about this Renban line? Is this, yeah, okay, that's got to be 3 and 5, hasn't it? Just to complete the column. So these two squares down here are a 3-5 pair. Now, what on earth do we do next? That is the challenge. We could ask the question, I don't know. I really don't know, actually. Maybe I've got to tidy up some Sudoku to sort of... This is a 6 or a 7 and it's on a Renban line. So have we got, I mean, obviously you can't put 1, maybe 1 in this column is what I should be thinking about. But the problem is these wing cells here, here and here, these two dominoes, are actually not restricted in the same way that they were over in column 1. I almost feel like this is going to be a bit tricky to figure out. Oh, no, hang on, maybe it's these two cells. Yeah, actually that's not such a bad idea. Because if we think about the possible combinations for this Renban line now, what it can't be is 4, 5, 6, because that's going to break this cell. And it also can't be 5, 6, 7, so that's going to, because that's going to break this cell. So this Renban line has to be at least, it's not 4, 5, 6, it's not 5, 6, 7, at least 6, 7, 8. So if it's at least 6, 7, 8, it does have an 8 on it, and I suppose it has a 7 on it as well. And it's either 6, 7, 8 or it's 7, 8, 9. So there is a 7 and an 8 on this Renban line, and that's not an 8. Does this do something for us? So 7, 8 and 9 in this, or 7 and 8 in this box. We don't know there's no 9 on the Renban line. That feels like it's sort of important to me, but again, it's not really doing enough work. Oh, my phone is buzzing at me. Let me just check what this says. No, I don't know the answer to the question that was asked in the text, so I will carry on. Right, where shall we look now? There's got to be a 4 in one of those two cells. I can see that by Sudoku. 5. Why have I got 5s in one of those two cells? Why is that? Because if that's true, I can write a 5 into the grid there. That's strange. How did I get 5s into those squares? I don't trust that at all. 5 can't be here. Why can't 5 be in those cells? A 5 be in one of those two cells. That's really weird. When did I put these in? Was it a long time ago? That's really perplexed me. I can see no good reason for that at all. I think I'm going to take that out It might be right, and I might have done it for very good reasons, but what those reasons were is eluding me somewhat. Okay, so where should we go now? Oh, 2 must go down here using my green logic. So there's a 2 over here. That means 1 must be in one of those 2 squares, because that's what we did, that's what we learned before. So there's a 1 in one of these 3 squares. But it would be lovely to know about the 5s. I'm really perplexed by that. 4. Oh, I know what I'll have done. I bet you I looked at those 4s and then pencil marked 5s up there. That makes more sense to me. That is possibly an error I would have committed, but at least I caught it. Okay, so let us try and get back on track here. 7, 8, 9. That's quite interesting. If we think about where 7, 8, and 9 can go in this box, you can't put them as a triple here, because obviously the 4 would then have no place to live. You can't put it there, so this square needs to be a 7, 8, or a 9. Don't know if that's going to be enough though. Okay, I'm a bit struggling here to know what it is I'm meant to be looking at. I feel like I've ground to an almighty halt. I don't like grinding to an almighty halt. That square, that's a naked single. Yeah, okay. This square, I should have spotted this very quickly, but I think I've been discombobulated by the 5s. But let's take a look at this square. It can't be 1, 2, 3. It can't be 7, 8, or 9. So its only options are 4, 5, and 6. It sees 4 and 6, so it is a 5. Oh, no. Okay, so now those squares there are a 1, 3, 5 triple, and this square is a 6, I think. And that gives me a 6 here. Ah, now this 6 is giving me a 7 over here. That doesn't tell me whether this is... doesn't tell me whether this is 6, 7, 8 or 7, 8, 9, but it might tell me what the options are for these. Yeah, this can't be a 1 anymore, because this can't be a 6. So this is a 3, this is a 4. And this way round, oh no, that's not resolved, look. This we can make 7 either as 2, 5 or as 1 and 6. But that must be important. He says. But I can't see why. 1, 2, 3, 4, 5, 7, 8, and 9. So this is... Oh, okay. So this square has... Oh, yeah, the 4 over here is what's doing this. Gosh, I need to focus a bit more on my Sudoku, don't I? So this is a 4, this is a 4. There's a 4 in one of those 2 cells. One of these is a 7, 8, or a 9, and one of them is a 5. But I don't think we know which is which. This 3 is giving me a 3 up there, look, just using pencil marks. That places a 3 in box 9. That gets me my 3 and 5 resolved in box 7. There's now got to be a 5 in one of these cells in box 8, which means there's got to be a 5 in one of 3 cells in box 9. Okay, so do we think we can do anything more down here? Or is it going to be 1, 2, 3 here? So we've got to put 1 and 2 in this box somewhere. So whatever that is has to go there. So those 2 cells are the same. Let's colour those in. Don't like that colour, going to use blue. So this is a 1 or a 2. Now I've got a 1, 2, 3 triple in this column, so that's not 2. That places 2 here. So now, do we know more than we did about this or these possibilities. This square, yeah, okay, this might be interesting. This square here now can't be a 1, 2, or a 3, or a 7, 8, or a 9. So it's got to be a 4, 5, or a 6. Which means this square's got to be a 6, 7, or an 8. And that's nearly wonderful, but no, it's not wonderful. Bother. 1. Yeah, where does 1 go in box 9 now? I think it can only go into this cell, which places 1 in box 7. Yeah, there's a lot of intricacy here that I feel I'm missing out on. This 6 is telling me that square's a 5 as well, which I should think I've probably had available for a while. So that gives me a 2 here, a 1 here, a 1 here, a 2 here. And does that resolve anything? This 5 is removing 5 from this cell, so now we know this square's got to be even. Which means that, what does it mean? It means that, so these squares are 4s, 5s and 6s. Okay, not quite seeing how to do this. This square is just restricted by Sudoku of all things. It sees 1, 2, 3, 6, 7, 8 and 9. So it can only be 4 and 5, I think. This has got to be a 4 or a 5. Still not quite good enough though, is it? Still don't know what the composition of this Renban line is. And whatever the missing digit is from this Renban line, that will appear here. So that's a 6 or a 9 using that logic. These squares are not 5. Okay. Yeah, look at row 7 now. These two squares have to be 7s, 8s and 9s. That creates a triple on 7, 8 and 9 here, which forces this to be 6, which gives us this digit as 4, this digit as 5. So these two squares are now a 5, 6 pair. And what does that mean? 1, 2, 3. These are set. Yeah, okay. Let's carry on with this 7, 8, 9 stuff. Now I get a 7, 8, 9 triple in box 3, which means that square's got to be a 6, which shifts 9 onto my Renban line. So these squares are now 1, 4 and 6. That's not 6. That's not 4. And this square is now forced to be a 5 just to complete this row. This square is forced to be a 2 to complete the box. Okay. Feels like everything's gathering up towards the need to resolve these arrows in the middle. What are those two squares? They are a 4, 6 pair. Whoa, 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 misclick. 4, 6 pair. Right, that's a little interesting in relation to column 5, look. Because now, where does 6 go in column 5? The answer is in one of those two cells. So 6 is on an arrow. It's on a 3-cell arrow in the middle box, which can't add up to 9 because of this. So wherever the 6 goes, it must have double 1 on its arrow. So if this is a 6, that must be double 1. If this is a 6, that must be double 1, adding up to 8. So there's definitely a double 1. There's a double 1 on the arrows. So what does that mean? The other arrow then has to add up to 7 without using a 1. That's right, isn't it? So does the other arrow have to be double 2, 3 then? Or am I going crazy? Let's just take a look at this, just so that we can analyse it. So whichever way up the 8 goes, well, no, the way to think about it is whichever way up the 6 goes. Let's say the 6 is here. We now know this has to be an 8, and we know those two squares have to be double 1. Now, I think this is interesting for the other arrow, which obviously now has to add up to 7. But what digits can we put on this arrow now? This square cannot be a 1. This square, neither of those two squares can be a 1. So even if we put 2 in all 3 squares, that would add up to 6. And we can't put 2 in all 3 squares because of this domino. So the only way this works is with double 2, 3. Right, okay. So let's come back, because what that means is that this is a 6-3. It means this is a 6-3. This is just brilliant. This is absolutely brilliant. This is a 6-3 pair, and there's a 3 here. So that tells us the order. That's got to be the 6. That's got to be the 3. Those have got to be double 2. This has got to be 7. This has got to be double 1. And this has got to be 8. That is absolutely gorgeous. Now, what's this going to mean for all of these other things that we've got going on? I think we get rid of the pencil marks here now and see what we've got left to place. We've got 4, 5, 7 and 8. So we can get rid of 4s from those ones. Oh, that was rather useless. That can't be a 6 anymore. Oh, so the 6 seems to have to go there in box 6. That's a 3. That's a 4. That's a 1. Okay, so that's a 5, and this is a 1. And we can do a lot more tidying up than I was expecting in boxes 4 and 6. So this 2 is telling us the order there. That's a 2, 3. That's a 3, 1. And I'm immediately drawn to this square, I think, because I definitely can't add a 7 or an 8 to a 3, because this can't be a double-digit number. Beautiful. So this is 5. This is 8. And that means we can take 5 out. Look at all of those squares. So this is huge then. Yeah, this can't be 7 anymore, because you can't add 7 to 1 and get the number 7. There we go. Knowledge bomb from cracking the cryptic. So that's 8. That fixes my 8, 9. 9 and 7 go into the grid. Right, how does this one work then? Again, the only thing that will work here is we can't add 6 to get 9 to the 3, so it's going to have to be a 4 and a 7, which suggests this should be a 7 and this should be a 9. Now, is this working? That's now a 9, that's an 8. This is an 8, this is a 7. I'm hopeful. That looks like it's a 7. This is an 8, so this is a 9 and this is a 7. The 4, 6 is resolved. Yeah, this is done, isn't it, I think? Unless I've made an error, this is done. 4, 8 and 9. So this is 9, this is 4, this is 8. And in this box, we need 5, 7 and 9. So 9, 5, 7. Tick. Yes. That's absolutely brilliant. That is a superb Sudoku puzzle. And there are many things I love about that. I was about to try and just illustrate it with one thing, but I think that there's a whole world of cute deductions going on in this puzzle. I wonder why it's called Unity. I don't know. Somebody might have to tell me why it's called Unity. Maybe Playmaker will watch the video and let me know. But what did I like about it? I really liked the start. I like the fact that you could immediately put a 9 in, and then once you thought about it, you could actually work out the value of the Syzygy. That was very surprising and rather beautiful. Then I really liked column 1, and I liked the fact you could ask questions about things like where does 1 go, where does 2 go, because these 1, 2, 3 triples do so much work to restricting the Renban lines. Once you know this is a highest digit, that Renban line and that Renban line can't contain low digits, and that allowed us to get this. That allowed me to make use of the mod 3 idea. After that, I think I got a bit bogged down with the usual subject of Sudoku. Never mind. But yeah, after that it was all. What did we do then? I think we managed to work out some stuff here. and eventually these arrows over here yielded. But actually the finale was gorgeous too, because in the finale, yeah, once we worked out there was a 6 on one of these 3-cell arrows, that put double 1 on the other arrow, which limits the other arrow to not having a 1 on it at all and forces it to be 2, 3, 2. It's just, it really is stunning. It's stunning. Let me know in the comments how you got on. I do enjoy reading the comments, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.